Hello everyone, welcome to today's live webinar. Thank you for joining us today. I hope you can hear me loud and clear. I'm Michela Fassi, Communication Manager at Milestone, and I'll be your moderator for today's webinar. Today we are here for our live webinar titled Specimen Collection 2.0 Best Practices. In this educational webinar, we will see some valuable methods to properly handle tissues after the surgical extraction. Milestone has been in this field since 30 years. Our mission is to reduce patient anxiety by providing pathologists with technologies for same-day diagnostic results. Today, Milestone is proud to offer innovative solutions in different fields like frozen sections, cytology, sample handling, tissue processing, tracking, macrodigital, and reagents. Before we start, I wish to inform you that Milestone organizes these type of webinars once a month, and you can follow us on our LinkedIn and Facebook pages or on our website to stay tuned. Before starting, I kindly ask your attention for a few seconds. In this slide, you can see the main functions of the Zoom platform through which we are broadcasting. The meeting controls are at the bottom of your screen, and they hide if you are not using them. They reappear if you move your mouse. Your microphone will be off for the entire webinar. The slides will flow automatically during the webinar. For any technical problem, you can use the chat icon to write to the host. This webinar is intended to be interactive, so we encourage you to ask questions. And you can submit questions anytime by typing them in the Q&A box. You can see the icon in the bottom menu as well. We will answer as many questions as possible at the end of the presentation. And for all the questions that may not be answered live, we will reply by separate email. Now let's take a quick look at today's speaker. The speaker today is Federica Rubini, application specialist at Milestone since more than 10 years. Federica has graduated in biological engineering at the University of Milan, and she has wide experience in grossing stations, macrodigital, and vacuum systems. This presentation today will last about 45 minutes, and it will be recorded. Now, I think it's time to start, so now I will give the floor to Federica.
Thank you, Michela. Good morning and good afternoon, and welcome to this webinar. The topic of today is the biospecimen collection. What is the collection and how it's done today? When a tissue is extracted from the human body, the nurse takes care about the tissue. The tissue is inserted in a plastic containers. The plastic containers is filled manually by formalin. And later on, specimens in formalin are transported to pathology lab. This procedure is totally operator dependent and is done without any standard method. What we have to remember is that our goal is to do a good diagnosis. But to arrive there, there are several steps. This is the pre-analytical that affect the quality of the diagnosis. The pre-analytical includes all the steps that I have reported here. So it starts from the moment when the tissue is extracted from the human body up to the staining procedure in pathology lab. In this webinar, I would like to focus on the following steps. The collection of the specimen that starts from the moment when the tissue is extracted from the human body up to the transportation to pathology lab. What we have to remember, considering that to arrive to the final diagnosis, there are several steps, is first of all the domino effect. Each step will affect the quality of the following one. Another effect, very important, is the jigo effect. Garbage in, garbage out. If the quality of the tissue is damaged in the beginning, you cannot expect a good quality diagnosis. You can have, for example, the best tissue processor in pathology lab, but if the tissue inserted are already damaged, the quality will be for sure not good. So, considering the actual way of doing the collection, we have to do some consideration. First is regarding the quality of the result, because if you do some negative steps during the collection, for sure this will impact the final diagnosis. Here I have reported for you an example of an artifact that you can find in the result, in the diagnosis. This is called, this artifact, post-mortem change, and is due to a delay of fixation when a tissue is extracted from the human body. In this moment, the degeneration starts immediately. You have, if you don't fix as soon as possible, you can have drying, apoptosis, autolysis. But in the beginning, you don't see any problem. You will find the problems in the as artifact in the diagnosis. It's for this that we have to try to do something, because when you find the problem in the diagnosis, you cannot do anything. You cannot come back. Another important consideration is regarding the safety. Now, the nurse is totally in contact with the formalin, because the plastic containers are manually filled by formalin. So now the safety of the operators is not guaranteed. Last but not the least is the traceability. Now is a must to do the traceability not only in pathology lab, but in all the steps of the life of the specimen. So we have to document all from the moment when the tissue is extracted from the human body. This is, of course, for the patient safety. Let's focus on the pre-analytical. Since many years in the literature, the authors talks a lot about this theme because it's very important. There are many articles. Here I have reported for you some examples. For example, some articles show how many errors you can have in the pre-analytical, and some articles talks also about the collection, the error that you can have in the collection of the specimen. Other articles talks about a number of variables that you can have in the pre-analytical. It's for this that right now it's difficult to control the pre-analytical, because it's composed from many steps and variables. Other articles talks about the accuracy, the unsatisfactory accuracy. For example, here the authors shows that approximately the 20% of the current R2 testing may be inaccurate, and this is really not acceptable. We have also to consider the growing interest in molecular biology. So, if we want to arrive there, we really have to change our way of work. The procedures that have been good since many years ago, now they cannot be good for sure. If there is this interest in molecular biology, we have to start to consider that when we collect a specimen now, maybe this specimen should be useful for future studies. So we have to really take care about this specimen. Considering our actual way of collection of the specimen, we can find many limitations. Limitation about the safety, not only about the nurses that manually fill plastic containers by formalin, but also of the operator that transport the specimen to pathology lab, and also the safety of the operating theater that it can be closed if a spillage of formalin happens on the floor. Limitation, a big limitation is also regarding the quality of the tissue, because now all the process is totally operator dependent. Now the fixation is totally without any control and documentation. But to do a good fixation is very important to have a good diagnosis. Moreover, in pathology lab, if they receive specimen in formalin, then they cannot do biobanking or molecular studies. Another limitation is a big time consuming for the nurses, that they have to do many things, but they should stay the most of the time inside the surgery room. They need them. Last but not the least is the traceability. Now is a must to document all the steps from the moment when a tissue is extracted from the human body. This is always for the patient safety. If you don't document, if you have some errors, you cannot know what's wrong, and you cannot for sure solve. Let's see one by one all these limitations. The first is for sure the operator's safety. Formalin has been declared cancerogenic from many entities, from YARC in 2004, NCA in 2007, EU in 2016. So now it's really mandatory to implement extra safety for the operators. The actual problem of the operating theater, that is difficult to build, for example, fume hood, vented fume hood. So now the hospital are trying to different solution. For example, the most popular is and very effective is the vacuum technology. So by vacuum technology, and we will see better later on, the tissue are positioned in fresh under vacuum. So this will completely remove the formalin from the operator, from the surgery. Operator's time is another limitation. The nurse has low time and has to do many important stuff, because when the tissue is extracted from the human body, the nurse has to choose the correct size of the container, insert the tissue, fill the laboratory request, fill the plastic containers with a correct quantity of formalin. So all these steps are very important, but then the nurse has to come back to the surgery room as soon as possible. So there is really a need of automation of all these steps of specimen collection. In operative theater, if right now the procedure is manual, we are not robot, we are human, so an error can happen. If we manually fill plastic containers by formalin, something can go on the floor. But as you know, if there is a big spillage of formalin in the OR, the OR will be closed to be sanified and so on. But you can understand the damage of the OR, because if you have many planned operations for that day, this is really not acceptable. It's also a big limitation, the actual situation of transportation of specimen from theater to pathology lab. Why? Plastic containers filled by formalin, if they are not closed correctly, and sometimes you don't understand, but it's like that, you can have easily spillages, smell, the volume and the weight are very high, and in particular, there is no standard way of transportation. So for sure, for the people that makes this job is not easy, and also they are not safe regarding the formalin fumes. Traceability. Here I have reported for you some examples of how now the specimens are received. Of course, without any standard method. Sometimes here is reported as example, they use container, not properly containers, label attached everywhere. And please consider that with the plastic containers is very important also the documentation that should stay always in contact with the specimen. Unfortunately, we know that sometimes in a pathology lab, it may happen they receive a specimen without documentation, documentation without the specimen, or sometimes there is a mismatch, and this is really not acceptable. Documentation is now a must. It's a must to document all the steps from the moment when a tissue is extracted from the human body. We need to know, for example, all the details about the fixation. Fixation is so important for the quality, for the final diagnosis. And then all the information needed to really understand all the chain. For example, the operator name, the date and time of the operation, the temperature conditions, and so on. In the actual way of work, now there is not a documentation of the actual collection and transportation of specimen. Regarding the fixation, the limitation of the current method is that it is too much operator dependent. So the nurse, the first operation to do with the fresh tissue is to choose the correct size of the container. This is very important because the formalin should penetrate from all the sides. The tissue is fresh and it's very important to fix it in a proper way in order to don't have degeneration of the tissue. So if for example, the container is too small, the formalin will be not enough. As you know, the formalin hardens the tissue. So then in pathology lab, the tissue extracted may have the shape of the container. Another important point, considering that this operation is operator dependent, the formalin level is not standard, and it's possible that one operator insert the formalin and without, it's possible, we are human, the formalin loading in the plastic containers is not enough. Then when the container will arrive in pathology lab, the first perception is, it's safe, it's in formalin. But then if you open the container, maybe you find that the formalin level is not enough. Another consideration to do is the biohazard. The feeling if you receive a specimen in formalin is, I'm safe because the tissue is in formalin. The reality is that the formalin penetration at ambient temperature is like 1 millimeter per hour. So for surgical specimen, the biohazard risk will be for sure present, even if you receive in formalin, because in the center of the specimen, you will have for sure blood. Here I have reported for you some important parameters that were regarding the fixation. These parameters were also suggested by CAP. So the time, the temperature, the ratio, and the pH. Why we should control the fixation? Recent publication has showed how to do a document and standardized fixation will improve the immunohistochemistry results. So this is all considering our goal, that is to do a good diagnosis. How is done the fixation? Now in manual way, mostly overnight. They position in operating theater a tissue, and the surgical tissue will arrive probably the next day. So we'll say minimum 1 day, and overnight inside the plastic containers. So the variables are not controlled, and they are many and many. For example, we don't know how many hours the tissue stayed in formalin before the grossing in pathology lab. We don't know the temperature. We don't know any documentation available regarding the first fixation steps. Regarding the ratio, we look in the literature. In the literature, they don't talk so much. And if they talk, they say between 1 to 0.5 regarding ratio, up to 1 to 200. So you can understand that in the literature, the things are not clear. There is not a standard method suggested. If you ask to people, the common perception is, I'm sure I do 1 to 10, or even they say, I do 1 to 20. In reality, if you make an easy calculation, if you consider the volume on the standard plastic containers normally used, and if you consider the weight of surgical specimen, it's very difficult for the most of the cases to apply 1 to 10. So this is just an idea that they can practice and use the 1 to 10. If you really want to apply the 1 to 10, they should use not plastic containers, but big bucket. I have reported for you an example of these containers that I found in a hospital of Switzerland, but this is really not the reality, because they needed to use the bucket, are more practical. It's not possible for a surgical specimen to use all containers so big. In the literature, many articles right now has evidence on how now using a smaller formalin ratio will give in any case a very good fixation and immunohistochemistry result. For example, here I have reported for you an article of René Buesa, how much formalin is enough to fix tissue. I really suggest you to read this article, it's very nice. And the conclusion of this article was that the fixation is time and temperature dependent, but not dependent by the volume. And as you can see, reading this article, that the ratio used by the authors with good result was 1 to 2. 1 part of the specimen, 2 parts of the formalin. So absolutely not 1 to 10. Another limitation of the standard way of collection is regarding the biobanking and molecular studies. Pathology lab, to do these studies, needs to receive specimen in fresh, not in formalin. Otherwise, the studies cannot be done. It's for this reason that many hospitals started many years ago to use the vacuum technology, because there are now many studies that prove that a tissue sealed with the correct level of vacuum and positioned at 4 degrees, the quality for immuno and molecular studies is preserved up to 72 hours. Why the authors studied the 72 hours? Because this is the weekend, so this is what the hospital need. I have reported here for you some examples, but there are many more and more of articles regarding vacuum technology and molecular studies. I have chosen the article regarding different kind of specimen. We have here studies on thyroid specimen, breast specimen, colorectal cancer specimen. And the last article I would like to show you, because this was the biggest genome project done in UK. And it's very interesting because for this project, they choose the vacuum technology for the collection of the specimen. So after all this talk, what's the ideal solution? We need a solution that guarantees the safety of the nurses, the safety of the operator that transport the specimen to pathology lab, the safety of the OR that cannot be closed for a formalin spillage because they have every day many operations planned. We need a solution that guarantees the quality of the process. We need a procedure not operator dependent, a procedure where the fixation is standardized and documented. We need a procedure that allows the pathology lab to do biobanking and molecular studies when they need. And we need, of course, a procedure where the traceability is a must and is done in a correct way. In the last part of my presentation, I would like to give you some ideas from Milestone. Milestone works in the pre-analytical field since many years ago, trying to give some solution to help the people regarding their safety, to help also the quality of the specimen. We are not new. We have now more than 50 publications. So if you would like to receive, we are happy to send you, of course. And now we have thousands of installations worldwide. Now, welcome to the Milestone laboratory. And it's my pleasure now to show you in details these 3 ideas that can be useful for you. The first instrument that I would like to present is TissueSafe Plus. TissueSafe Plus allows to completely remove the formalin from the operating room. TissueSafe Plus is installed in the dirty room, so more operating rooms can use the same unit. TissueSafe Plus works with special bags. Of course, we have different size. The tissue, when is extracted from the human body, is positioned inside the bag. By TissueSafe Plus, is sealed under vacuum, and then the tissue is positioned at 4 degrees. So the tissue will be transported in fresh condition in pathology lab. In pathology lab, if they receive in fresh, they can do biobanking and molecular studies, and they can really control the fixation, because the fixation will start in controlled position at 4 degrees, controlled position in pathology lab. The transportation will be without formalin fumes, and also in operating theater, the nurse will be out of the formalin fumes. The procedure of the vacuum is very easy, very fast, I will show you, and all automated. So during this time, that is less than 1 minute, the nurse can, for example, do other things, like, for example, fill the laboratory request. We worked a lot, of course, in the tissue safety. Why? Because the type of vacuum is not direct. So it's normal inside the bag to have not only the tissue, but also biological fluids. All the fluids will stay inside the bag because the vacuum is not direct. Moreover, in Tissue Safe Plus, we have 4 different programs of vacuum. The different program are related to the type of tissue. What we look at is the elastic or plastic point of the tissue. Now I will make a practical demonstration, and I will show you another important aspect that you have in working with Tissue Safe Plus, because it's the traceability. We have a barcode reader to scan the ID of the bag, because we have the traceability of the bag and also of the case in the laboratory request. So now, very easy, I scan the ID. I scan also the ID of the case. Each bag has a sealable pocket. So always the document will travel always in contact with the specimen. No possibility of losing any documentation. So now I position easily the bag. I select the program and I close. To complete the traceability, here we have a printer. So in the end of a run, the instruments will print a label with all the information. The bag ID, the case ID that now I link, the date and time of the sealing, and all the information that the hospital requires. For example, the name of the operator, the name of the surgery, the type of the specimen, all that they want. So now, as you can see, the process is very fast. Now I have the label with all the details. The label will be attached to the bag. This is the result. As you can see, the volume is very small and the weight, and this will be positioned in controlled condition at 4 degrees. The second instrument that I would like to present you is Seal Safe. Seal Safe is like Tissue Safe Plus. So Seal Safe is installed in the dirty room, so multiple operating room can use the same unit. Seal Safe can work like Tissue Safe Plus. So by Seal Safe, you work with special bags. We have different sizes. And by Seal Safe, you can seal specimen in fresh. So the specimen sealed by Seal Safe without formalin can be transported at 4 degrees in pathology lab. So by Seal Safe, if you want, you can remove the formalin from the operating theater, from the transportation, and in pathology lab, they can do biobanking. In addition, in Seal Safe, you have a double possibility. Why? Because Seal Safe has here a vented drawer where you can connect up to 20 liters tank of formalin. On the back of Seal Safe, you can also connect the unit with the big bulk of formalin if present in the hospital. And inside the cavity, we have a scale. The scale will measure the weight of the specimen. The instruments, in a total automatic way, will load a fixed and standardized quantity of formalin. So, in cases when they want, it's possible to position inside the bag tissue and formalin, but in an automatic way. So the nurse will not be in contact with formalin. And during this time, the nurse can do other job, like filling the laboratory request and so on. This is the result. a particular point in SealSafe, after the fluid injection, we apply a standard vacuum that removes the air from the bag. So the tissue will not float in the formalin. The tissue will stay inside the formalin. So in SealSafe, the volume in any case of the formalin used is less than the standard way of collection of the specimen. A question that you may ask me is, okay, you send the specimen in bags, but then in pathology lab, what I do? In pathology lab, if you work with TissueSafe or SealSafe, it's the same. In pathology lab, you will have another SealSafe. Why? Because the bag, each bag will be used all the life of the specimen. So in pathology lab, they can use SealSafe to fill again the bag for an extra fixation of specimen. And in particular, you can use SealSafe to do the archive of tissue in bags. The very good important point is that if the tissue is well fixed, you can do the archive of specimen just by vacuum without formalin. So there is, with working with bags and SealSafe, a very big improvement in the archive in pathology lab. They don't have smell, they reduce volume and weight. Even if you do the archive with formalin, there is a very big reduction of volume and weight. And so this is a very return of investment of the hospital. The last ideas of Milestone that I would like to show you is UltraSafe. UltraSafe, like TissueSafe Plus and SealSafe, is installed in the dirty room. UltraSafe works with plastic containers. Of course, we have of different dimensions, up to 10 liters. We have two kinds of plastic containers, transparent or not transparent. And these plastic containers are very particular because on the top of the plastic containers, there is a non-returning valve. This allows to do this operation. The nurse insert the specimen in fresh, so when the bucket is empty. Then they close the bucket and they will not open anymore. So even with UltraSafe, the operator is not in contact with formalin. Then the bucket will be inserted in UltraSafe. UltraSafe has a scale like SealSafe. So in UltraSafe, we measure the weight of the specimen and we load automatically a fixed quantity of formalin. So in UltraSafe, the same like TissueSafe Plus, the same like SealSafe, we load a fixed quantity of formalin. So we standardize the formalin documentation. The operator is not in contact. The process is all automated. And when the bucket is filled by formalin, then the bucket should not open anymore. It will be open in pathology lab. On the frontal part of the UltraSafe, we have a drawer like SealSafe where you can connect up to 4 big tanks of formalin. On the back, you have again the possibility to connect the unit to build bulk of formalin if present. Like TissueSafe, like SealSafe, we have a barcode reader and a printer. So you will have a perfect traceability of all the steps. In particular, in SealSafe and in UltraSafe, in the printer, we will print all the details about fixation. So you know the formalin ratio, the formalin weight, the specimen weight. So with these two instruments, we're working with formalin, but we document the fixation. So in pathology lab, they know what time the fixation started. And in addition, the formalin is managed totally by the unit, not by the nurse. Now I will make for you a practical demonstration. So I will scan the ID of the bucket for the traceability. Also here we document all. The ID of the case is present. Now I will insert the bucket. I close, select the program. And then in automatic way, the bucket will be loaded by a fixed and standardized quantity of formalin. Particular point is that these cavities, when the operator is not using the unit, you can plan, for example, during the night, you can run a UV decontamination process. This is useful also against COVID decontamination. So now the loading procedure is done. In the end, in ultra-safe, seal-safe, and tissue-safe plus, you can activate this card, named temperature data logger card. By this card, you can load all the case name of the specimen sent. So then in pathology lab, they can control if all the specimens sent have been received. This is also important for the traceability. This card is very useful also in tissue-safe plus or seal-safe, because this card can monitor the temperature of the refrigerator. So if you send a specimen in fresh, by this card you can document that your transportation was done at 4 degrees. Okay, now I have here the label that you can have also in safe with all the details also about the fixation. And now here, so the nurse should only to close the valve, not open. So the nurse is really not in contact with formalin. Last important point regarding the safety is that in all the 3 units, we have a built-in HEPA filter and also formalin filter. This is just to conclude, because I have talked a lot. So just to make easier the description. Tissue-safe plus allow to seal specimen in fresh without formalin with a dedicated not direct vacuum. So in pathology lab, they receive specimen in fresh, they can do biobanking and molecular studies. All the procedure is standardized and documented. With seal-safe, we work with bags, and you have double possibility. You can send in fresh or you can send a specimen in formalin, but all is done in an automatic way. All the fixation is controlled by seal-safe. With ultra-safe, you use buckets, but like seal-safe, there is a scale, so we really control all the fixation parameters. And by the barcode reader, by the printer, by the temperature data logger, all the steps are documented and controlled. My presentation is finished, so now I will be happy to answer to all your questions. Thank you.
Thank you, Federica, for your nice explanation. We are actually ready for question and answers. So I'm gonna read out the question that I have received already, and in the meanwhile, feel free to write your question in the Q&A box. So the first question is about the vacuum injection. Will it impact on the specimen?
Okay, thank you for the question. Okay, we go to our tissue-safe plus. Tissue-safe plus has been designed to be totally safe, not only for the operator, but for the specimen. In tissue-safe plus, the type of vacuum is not direct. What does it mean? Take the bag, tissue inside, the bag is positioned inside the cavity. How we apply the vacuum? We remove the air from outside the cavity. So the vacuum is not direct on the tissue. This is very important because if you have some biological fluid, blood inside the bag, this liquid will stay safely inside the bag during the creation of the vacuum, because the vacuum is not direct and we don't extract the air from the bag. Another important point regarding the safety of the specimen is that in tissue-safe plus we have 4 dedicated vacuum programs. The program has been tested and created working with hospitals over the world. The type of the program depends on the type of tissue, on the elastic and plastic point of the tissue. And it's very easy, the selection of the program, because here we have a software that will guide the operator to choose the correct size of the program. Last interesting thing is that it's possible with tissue-safe plus to work with, for only the most delicate specimen, With polystyrene containers, we have two sides. Particular point is that we have holes on the top of the containers. So the tissue is inserted in this container and the container is positioned inside the bag. Due to the holes that we have on the top of the plastic containers, the vacuum applied will be directly applied also on the tissue. There is no really a need to have this because the program are correct. These containers are useful because you can not touch too much a delicate specimen. Imagine that you have a brain. If you have to insert the brain or extract, it's better to have this to protect more a specimen from a handling.
Okay, let's move to another question. Is the vacuum system connected with the LIS, Laboratory Information System, or does it use a standalone software?
Okay, good. All Milestone unit can be very easily integrated with all the LIS. I can say that is a plug and play because we have available a middleware named MileWatch. By this middleware, all our unit can be easily connected to the list. So the list can take all the data from our unit. Another interesting thing is that with MileWatch, if you want, for example, you can also imagine in a pathology lab, they can have a software, a viewer software. So in pathology lab, they can know in advance all the specimens that are arriving to the operating theater. Maybe this can be useful for them.
Okay, another question is this one. What about bag storage versus container storage in wet archive cabinets? What about space and ease of storage?
The use of bags takes a really big advantage for people of pathology lab regarding the archive. Why? Because in a seal safe, you have double possibility. You can load formalin or just seal without formalin. If a tissue is well fixed, you can just seal a specimen in the same bag of the beginning. So here you have all the documentation without formalin. So in the archive, you will have a dramatically reduction of the space, the 80% of reduction of volume and weight. So you will not have smells of formalin in the storage. If you need to dispose of the specimen, separating specimen or formalin, you don't have to do this job because you don't have the formalin. So the hospital will pay really a lower amount of money for the disposal also of formalin and of specimen. So the advantage is not only for the operator, but also for the hospital. In case the tissue is not well fixed, it's possible by seal safe to load a small amount of formalin. We have really thousands of installations of all the world. I can tell you that to do the archive with formalin in bags, the amount of formalin loaded is just 1-to-1. So really the spacing, in case if you do an archive with bags and formalin, you gain regarding space and volume the 50%. That is quite a lot. Moreover, from the bags, we have a double sealed, so you will not have spillage and a smell of formalin, a smell that if you normally go in one archive, you can really feel. So this is also very important for the safety of the operator.
Okay, another question. Does Milestone have a solution to store the plastic bags for the archive?
Okay, I can tell you from our experience that people normally take boxes and position bags just one by one. Then very interesting because by seal safe it's possible to seal a label with all the case ID sealed in the day. So you may have a box with on the front this label with all the case ID. So then it's very easy to find your case ID from the label and to choose the box with all the bags positioned one by one.
Thank you. Let's move to another one. This is maybe a repetition, but let's do it. Can we use Seal Safe for sealing tissues with and without formalin?
Exactly. The good point of Seal Safe is this, that by Seal Safe, if you install Seal Safe in operating theater, you have double possibility. You can send a specimen without formalin in fresh, or you can send for a specimen with formalin, all done automatically by Seal Safe. In pathology lab, you can use Seal Safe to load, for example, formalin, to do a fixation with a new formalin, to do an archive with formalin, or in pathology lab, you can use Seal Safe to seal without formalin well-fixed specimen for the archive. It's good, for example, in operative theater, maybe you can choose, I want to send some particular kind of specimen in formalin, some other type of specimen where I want to do biobanking in fresh. So Seal Safe is really a very complete unit and versatile, I can say.
Thank you again. We are actually receiving a lot of questions. Let's do a few more. What is the minimal size tissue that is possible to be used with the Tissue Safe or Seal Safe?
Actually, we normally we suggest first of all, we have this is the smaller size of bags, and we have available for very small tissue like a spindle that is a container smaller than this with a hole. Of course, the needle biopsy and the small biopsy becomes dry very, very fast. So the suggestion is for the needle biopsy, the very small biopsy, to continue to use the pre-filled container of formalin. Then you can start using our bags. Considering that Milestone always thinks in the safety of the operator, we have developed FormSafe. FormSafe is a pre-filled container of formalin with on the top a hydrocarbon layer. This hydrocarbon that always, even if you squash the container, will stay on the top, prevent the formalin fumes. FormSafe complete all the chain. So our suggestion is for the very small specimen, the needle biopsy that becomes dry very fast, it's better still using a pre-filled containers of formalin. For the other kind of specimen, to start to use this kind of bags. If you see the bags, maybe you can say, oh, the bag is quite big, but in reality, no, because you have to consider that the bags will be used all the life of the specimen. So here, this is the first sealing in operating theater, but then here you can seal many times that you need in pathology lab.
Thank you, Federica. I think that this will be the last question because we are running out of time. Let's focus on ultra-safe. Okay. Do we have any risk of spillage with this unit?
Okay. So I will just focus here on the central part of ultra-safe. Absolutely not. Ultra-safe has been designed to be safe regarding the operator and of course the specimen. I will now open the cavity and I would like to show you some of the safety procedure and components that we have here. First of all, you can see that here we have some circles. This is a very clear indication for the operator on where the operator should position the bucket. Moreover, we have here 3 spindles, okay, that when the program starts, the spindle will, even consider, for example, imagine that I position the bucket not in the center, the spindle in the beginning of the program will move the bucket and they will position in the center of the cavity. The spindle has a second functionality. They will detect the presence of the bucket. So if they detect that no bucket is present, the program will not start, so the formalin will not release. Moreover, here we have a scale that measures the weight of the specimen. The scale will detect if the bucket is not present. Again, the formalin will not be released. Very important for the safety is this. This is the formalin injection. As you can see from this movement, we can understand from this sensor, okay, if the bucket is present or not. Moreover, we have here also an overflow sensor. So if the sensor detects the formalin present, absolutely the formalin loading will be stopped. Very important to say also is that here we have a drop-proofed valve. So after the formalin injection, any drop of formalin will be released on the cavity. The last interesting part that maybe I can give you a faster demonstration. As I told you, you have to start the program with the valve open. Imagine that for a mistake, the operator will insert the valve closed. Absolutely, the formalin will not be released because from this movement, this sensor will understand that the valve is closed. So now, just start a run. Open. I will show you that I will insert the bucket not in central part. So you can see the spindle, okay, how they act. First message, bucket may be empty. Do you want to continue? So we know already from the scale that probably the process is will not be. You see the spindle position in the correct position, in the correct central part, the bucket. Now, you see the formalin injector come up because it detects that the valve is closed. And now here, bucket valve closed, I have the message. So as you can see, it's really not possible to release the formalin if we are not in the correct situation.
Thank you, Federica, for your explanation. I think we are running out of time, so for all questions that have not been answered live, we will reply by separate email. I just would like to share with you a final slide with our contacts. In particular, if you're interested in knowing more about our products, of course, you can ask for a virtual demo and our application specialist will be happy to provide demonstration and solutions of all our products. Also, if you want to save the dates for next educational webinars, here are the next dates and registration will open very soon. You can stay up to date by following us on our social media or checking our website. Thank you everybody for watching and participating. You will receive an email message tomorrow with the recording of the webinar in case you need to rewatch it on demand. Thank you again for your participation and we hope to see you all next time. Goodbye and arrivederci.
Bye.